three simple steps. So if you can do what we just did with the simplifying expressions, that's what it means by combined like terms. If you can simplify expressions on both sides of the equal sign, and then all we got to do is move variables on one side of the equal sign and all the numbers on the other side. And then you guys remember what the coefficient was, hopefully. The coefficient is the number being multiplied by the letters. All we've got to do is divide by that. Now that may require some, in some cases, fraction division. It won't yet, but it may in the future, which again we'll go over when that time comes. So we've gone over one thing really right now. So far we've just gone over expressions. Very relatable concept. Expressions, but now we're looking at equations. Let me show you the difference here in equations. So if I had an expression can be just a number, because we're looking at a math expression, 2. Maybe sometimes we'll add like a 7x right here. This is an expression. And an equation differs only like this, okay? So let's say we had the same expression, 2 plus 7x. But an equation now is going to include an equal sign like this. And of course, it should equal something like, I don't know, 5, okay? An equation allows us to solve for the value of the variable or the unknown, which is good, okay? Now, we're going to use what we call principles of equality. Principles of equality include the inverse, the additive inverse, and then inverse operations, which really is just dividing by the coefficient. So one of the skills we need is being able to know what to add or subtract to something to get 0. So for example, you guys give me a number? 13. What would I have to add to 13 or even subtract from it in order to get 0?
5 and 8.
What's that?
5 and 8.
Okay, let's just combine them and make it 13. Right there, right? Sorry, yeah, you went a step beyond, and that's okay. 13, right? Let's look at another example. Let's say that we had -5. What would I do to I don't want another 5. A 0. What would I have to do to -5 to get 0? Add 5. There you go. So as long as we can understand this, then we're on the right track to solving equations. But in some cases, and this has to do with the second step right here, moving variables and numbers to their own side of the equal sign. This is the additive inverse stuff. So let's say that somehow we had 14x. Well, what would I have to do to 14x to get 0? So this one's a little tricky because it's not a number, but it's the same concept. All I've got to do is subtract itself. I would just subtract 14x. Now I have 0, and that's really what we're looking for what we need to do to solve these equations. Now we have this inverse operation stuff, but that's really just dividing by the coefficient. So number 5. This is a very basic problem. Solve the following equations and check your solution. And we'll talk about checking the solution here in a moment. But let's just look at solving this. So the idea for solving these is that we want to know what the value of the letter is. In this case, we have an A. All I want to know is what A equals. I don't want to know what A minus 42 equals. So how do I make that just an A? Yeah, very good. See, if I add 42 to this, what's negative 42 plus 42? 0. Now, if I do something to one side of the equal sign to keep it balanced or equal, I have to do it to the other side of the equal sign. So I need to add 42 to that 37 as well. So again, that makes this a 0. That's what we wanted because we just want the A. A plus 0 is just A. And by adding these, I got a 9 and a 7. So A would be 79. Now here's what they mean by check. So we're going to rewrite this equation. And I'm showing this to you knowing that technically, or in the past, my experience shows that about 1% of my students will actually do this step. Now you don't even have to show the work for it. As long as you do it, that would be great. Especially since you guys can use calculators on the rest of the tests. But checking the work means that, see how we had that A? I'm going to replace that A with 79 and just see if I have a true statement. I put plus 42, it was minus. That was going to come out very bad. Well, 79 minus 42, again, that's something you could just check in your calculator. I get 37. And then we just see, is this a true statement? Yeah, that's true. So now on a test, we've just kind of showed you a legal way to cheat. But most people don't like the legal way. They would rather do it the old-fashioned way. But don't cheat. Number 3 is y equals negative 4 solution to 2y equals negative 8. Well, let's find out. So this is where we would be checking our work at the end. You solved the equation. You said, oh, y is negative 4. Now we're just checking to make sure that it is. You'll always check in the original equation. This skill is pretty crucial because later on in 980, there's a section where if you can't do this, then a whole module is thrown out. And there's only 5 modules in 980. So this is 2y. But y right there is negative 4. So I'm replacing y with negative 4, which kind of looks like a y. And this should equal negative 8. I put a question mark over that equal sign because we're not sure yet. 2 times negative 4 is negative 8, which does equal negative 8. That's true. So is it a solution? Yes. Is x equals negative 3 a solution to this stuff? So again, I'm going to replace x with this negative 3. So negative 3 divided by 2, does that equal negative 6? Well, as a decimal, that'd be negative 1.5, which again, your calculator would show you. Does that equal negative 6? Nope, that one's false. Negative 1.5 does not equal negative 6, so is it a solution? No. Let's go back into this problem. What value of x would make this a true statement?
12. Negative.
Very good, yeah, it needs to be negative, yep. So x would have to equal negative 12. And we'll show you guys how to do that here in a moment with these fractional types. All right, 12 is good practice. We need to solve for that x value. Now again, the objective here is to make this x plus 0. Well, how do I make that x plus 0? Because right now I got x minus 2, right? How do I get rid of that minus 2?
Add a over.
There you go. Add 2. But if I do it to one side, I must do it to the other side. So negative 9 plus 2 would equal negative 7. So we got that x plus 0. That's just going to give us x if we were to actually evaluate that. Well, we found the value of x. That's great. Let's go ahead and replace that x with negative 7 in the equation and just see if it gives us a true statement. So negative 7 minus 2 is negative 9. This is true. So we know that this is correct. X equals negative 7. So on 6 we got x divided by 6 equals 5. Now I said to divide by the coefficient, but we haven't learned how to deal with fractions yet. So on this one we're going to use inverse operations. This is division right here. So to get rid of it, I just need to multiply, and again we have to do it to both sides, by some number. Well, if I multiply this by 6 on both sides, these 6's right here will cancel out, which just leaves us with this x, which is what we wanted. And this tells us that x equals 5 times 6, which is 30. Now again, we can check that. We should have 30 divided by 6. Does this equal 5? Well, yeah, 30 divided by 6 is 5. So that is true. And we know that our answer is correct. So number 10 right here, this is n divided by 11. So I need to undo that division by multiplying by 11. Now here's what this would look like if we'd written it as a fraction. N over 11 equals 9. So it's no different than what we did on that last example. Multiplying both sides by the denominator allows us to eliminate those 11s. And we're just left with the n, which equals 9 times 11, which is 99. And again, we could check that 99 divided by 11 is 9. And we know that our answer is correct. Alright, so that's not a lot of problems in this section. That's because all of these are considered one-step equations. We can solve them in one step either by addition or subtraction or by multiplying both sides by some number, or in some cases even dividing them, which again we'll get. Actually, we didn't do one of those examples, dang it. Let's look at number 14. 14, 60 equals negative 6, and that would be times a. So we need to identify that. To get rid of multiplication, we'll just divide. But if I do it to one side, I got to do it to both. Now, again, the objective is to make this a 1a right here, so that we just have an a all on its own. Of course, we don't really need the 1 there either. So I got negative 6 there. How do I get that negative 6 to become a 1? It's close. Instead of multiplying, we would divide. Anything divided by itself is 1. So if I divide that by negative 6, I do get that 1a. And then I got 60 divided by negative 6, which would be negative 10. And again, we can check that. Negative 6 times negative 10 is negative 60, so that checks off.